Okay, AV Calculus AV, Unit 9, Day 9, office hours for the pretest. I cut short my other video and I'm going to finish it right now. Probably not going to take super long, but this is the last page of the pretest. So here we have a graph of the derivative and we know a value f3 equals 40 and we're going to find these other ones. So the whole idea behind these is the fundamental thermodynamic calculus part 1 that we used on 1819. So if we're going to integrate f prime of x, that'll give us f. And then if we go from 3 to 5, we're going to get f of 5 minus f of 3. And so then we're trying to find f of 3. No, we're trying to find f of 5. So f of 5, if we solve for it, it's going to equal f of 3 plus the integral of 3 to 5 of f prime of x dx. And so f of 3 is 40. And this is going to come from find the area of this graph. So from 3 to 5, I'd probably just do trapezoid. You could do a triangle and a rectangle, but that's up to you. I'm going to say, all right, I'm going to just show the work down here. Average of the bases are 4 and 8. Height is 2. Average of the bases times the height is 12. So this is 12, this whole thing. So it's going to be 12, so it's going to be 52 is f of 5. Okay. Same idea here. If we integrate f prime of x, we get f. If we want 8, and we have 3, so we're going to go 3 to 8. It's going to be f of 8 minus f of 3. Trying to find f of 8, so f of 8, if we solve for it, would be f of 3 plus the integral 3 to 8 of f prime of x dx. F of 3 is 40. 3 to 8 is going to be all of this. So we already did this trapezoid, so we might as well take advantage of that. And this one, this is a rectangle. 3 times 8 is 24. So that's going to be 36. So we're going to get 76 for the value of f of 8. And f of 0, so we're going to do integral of f prime of x dx. We get f. Now 0, and we have 3. I'd put 0 down here. I mean, it's up to you. Because if you go backwards, then it's going to get a little tricky. So I'd rather not go backwards when I'm integrating. And so f of 0, if we solve for it, we move this over here, subtract this over here. It's going to be f of 3 minus 0 to 3 of f prime of x dx. And f of 3 was 40. So we've got to find the area from 0 to 3, which is another trapezoid. So I would just do average of the bases, 6 plus 4 divided by 2, times the height is 3. So that's going to be 15. It might be good for you to show some kind of work. Help me follow how you're getting these values, because they might come out really wrong for simple reasons. So you should expect something like that on your test. Graphing calculator, f prime of x, so the same idea. If we integrate f prime of x dx, we get the original function, fundamental thermodynamic calculus part 1. If we plug limits in, if we have 2 and we want 5, I'm going to do smaller to bigger. It's going to be f of 5 minus f of 2. So f of 5 is going to equal f of 2 plus the integral of 2 to 5 of f prime of x dx. So f of 2 is 10. And then we're going to do this on our calculator. I'm going to say, okay, 2 to 5 of e to the x times x cubed. Now, you could try and do this by hand, but you have a calculator. Number one reason not to do it by hand. Also, you just can't do it by hand. So on your calculator, it should be super fast. 10 plus math 9 e to the x times x to the third, comma x, comma 2, comma 5. Done. It's that easy. So 10,977.795. 3 decimal, actually rounded or truncated. I'm not going to let's see. Okay, so next one, same idea. If we integrate f prime of x dx, we get f. We have 8, we want 1, so I'm going to go 1 to 8, f of 8 minus f of 1. This is what we're trying to find, so I'm going to solve for that. F of 1 equals f of 8 minus 1 to 8 of f prime of x dx. And so f of 8 is 2. And then we're going to integrate 1 to 8 of x squared natural log of x, which you can't integrate by hand yet. I'll teach you how in Calc BC. But even that, you're still going to run into problems that you can't integrate by hand, even in BC. And who cares? You have a calculator, so take advantage of it. So it's going to be 2 minus math 9 x squared natural log of x, comma 1, comma 8, and then we get the answer, negative 296.113 truncated, or negative 296.114, rounded this time. All right, these ones should be super fast. This is fundamental theorem of calculus part 2, derivatives undo integrals, and then you plug limits in. But you got to remember the chain rule. You got to still take a derivative of what's inside. Like everything in here has been taken care of, but that's a new thing that we haven't taken a derivative of. So I usually leave a little space right here, and then I multiply by the derivative. I usually put it in front. I know a lot of times you put it in the back, but I'm going to want the front anyway. So usually now I'm doing it in my head or whatever and just put it in front. Cosine of 8, you got to multiply derivative of 8, which is 0. So that term drops out. 3x squared cosine x cubed. I still want to see this in your work. Otherwise, I'm going to just think you didn't think of it. Just got lucky. Okay, same thing here. Now, when I plug these limits in, I usually try and plug them in parentheses first, especially on these problems, because then I got to multiply by the derivative of what we plugged inside, but only that, 2e to the 2x. It has its own little chain rule, extra 2 pops out, minus sine of x cubed to the 4th, which is x to the 12th, but I don't want a 12x to the 11th here. I want a 3x squared. Just what you plugged in, okay? Final answer, simplified 2e to the 2x sine e to the 8x minus 3x squared sine x to the 12th. That's your answer. Okay. All right. Last one. This is saying, okay, do u substitution. So then du would equal 3x squared dx, and x squared dx is good. I don't want the 3. So then we would rewrite it as 1/3 cosine of u du. Now, if I'm trying to pick an answer with all u stuff when I'm done, I got to change the limits. These are x limits. I usually don't bother because I change it back to x and then just use the original x limits. But if you're going to write an answer with u, or pick one from multiple choice, you got to change the limits to u limits. So it's easy. You just plug x equals 1 in here, and you get u equals 3. Plug x equals 3 in here, you get u equals 11. So it's going to be 3 to 11. Oh, shoot. Did I make a mistake? Oh, no. 27 plus 2 is 29. I did 3 squared. 29. 29. So, all right. Okay. 26 if f of x is odd. So you might sketch like an odd function, like a cubic or a sine curve. And it might just help you kind of wrap your head around what we're doing. So 0 to 2, they're saying 0 to 2 is equal to 3. Okay. Then 0 to negative 2 to 0 over here, well, that would have to be negative 3 because it's an odd function. You get the same area. That's going to be opposite sign. This right here, we'd say negative 2 to 2. Let's break it up. Can't just add 5 to the answer. You got to integrate the 5. Now this is going to be negative 2 to 2, which if you just use what we did, negative 3 and 3 together is going to give you 0. And then the antiderivative of 5 is 5x. You could use a geometric approach for this because it really is just a flat line. going 5 from -2 to 2, and it's just going to be the area of rectangle. Base times height, 4 times 5 is 20. Or you could do it this way, 5 times 2 minus 5 times -2 is 10 plus 10 is 20. All right, that's it. That's the pretest. Be ready for your test.